In this video, we'll be looking at some titration curves and different parts of a titration curve. What is a titration curve? A titration curve is a way of sort of visualizing what's going on with concentrations of different species in our reaction as a titration is happening. It helps us to sort of understand why we can see an endpoint, what sort of physical properties are changing pretty drastically there, and what's controlling the concentration at different points of the curve. So a titration curve will generally look something like this. Our x-axis is going to be a volume of titrant added. So this is a way of tracking what's happening as we are adding our titrant from our burette into our solution. And on the left will usually be a concentration of one of the reactants. And because these concentrations are going to change by many orders of magnitude, they're usually written as px, where this is like pH. Px would be equal to the negative log of the concentration of x. And this allows us to track very large changes in concentration on a reasonable scale. So this is a logarithmic scale. This is a log base 10. And this is a way of keeping track of what's going on. So a titration curve might look something like this, just to give an idea. This is sort of the general shape that we'll see for titration curves. It could be flipped and start low and go high, depending on which reactant you're looking at. But sort of the features that we're going to see here are this sharp point here. This is the equivalence point. And we see a very big change in the concentration of the reactants at this point. This is where our reactants are all getting used up, and we're going to afterwards have, a lot of excess of the thing that we're adding, right? So usually a curve that looks like this, our y-axis here is in terms of our concentration of the titrant. Basically, there's very little of it to start with, which is a very high px value, and there's a lot of excess of it after you get past the equivalence point, because it's already reactive with everything it's going to react with. Okay, so we sort of have different regions to this curve. We have the before the equivalence point, and this will be controlled by the equilibria, and then after the equivalence point, and one other, at the equivalence point will be its own thing. And then we also have the, before anything happens. Those are sort of our parts of our titration curve. And we're going to look at what governs the concentrations at these different parts of the curve.